Hi guys, it's Miss Tammy. We're going to review what we've learned in Chapter 8 for your test on Tuesday. The first thing I wanted to go over was graphing systems of equations or solving systems of equations by using graphing. So to do that, you have to look at your system of equations here, and they have to be in y equals mx plus b form. And they're not right now, so we need to solve them to put them into y equals mx plus b form. So we're solving for y in each equation. Okay, so what we need to do for this equation first, always just go step by step. We need to isolate y, so we're going to subtract 2x from both sides. Then we get y equals negative 2x plus 3. Okay, now for this one, we need to get the y by itself here, so we can just divide both sides of the equation by 3, and we're going to flip it around, so we would get y equals 1/3 x, and then negative 12 divided by 3 is going to be a negative 4, minus 4. Okay, and then we come over here after we have them in our system of equations in y equals mx plus b form. We come over here and we first graph our first equation. So positive 3 is our y-intercept. Then we're going to use our slope to finish drawing the rest of the line. Our slope is negative 2/1, so we go down 2 and over 1. Down 2 and over 1. Down 2 over 1. Alright, and then we can draw that line. And we'll see if that's enough points for that line. Okay, and then we need to go ahead and graph our other line. Okay, so our y-intercept is negative 4. Okay, and our slope is 1/3. So we're going to go up 1 and over 3. Up 1 and over 3. Alright, and we'll draw that line. And as you can see, these 2 points intersect, or these two lines intersect at the point 3, negative 3. So our, okay, so our solution for this, we look for the point where the two lines intersect. So after you graph the two equations, you look for the point where the two lines intersect. If they don't intersect, then there's no solution. If they do intersect, then the solution, you just write down the point at which they intersect, and that's the solution. So for this problem, the solution is 3, negative 3. Okay, and that's how you solve system of equation by graphing. Really quickly, just to review, if you were going to solve this system of equation by using a table, you would make two tables with x and y at the top, okay, and a line down the middle. That's not a very good straight line, but then you would just choose numbers for your x on both sides. They could be anything. You could do like -3, -2, -1, 0, 1, 2, 3 on both sides. Then you just come up here to your two equations and go with the first one first and go ahead and plug in all the numbers that you chose for x, and then do the math here and solve for what y would be. So for instance, if x you chose to be 1, you would say -2 times 1 is -2, plus 3 is +1, okay, and that would be your y. And then you would just go down and find out all the values for your y's. And then you would do the same thing for your second equation. And what you would be looking for in these two tables is for one of the x and y value combinations to be the same. And once you find the one that's the same, that's going to be your solution. I'm not going to show you one here, but I just wanted to quickly review that and remind you guys that if you solved a system of equations by using tables, you would be looking for an x and y value in each table to be the same. Now we're going to review solving systems of equations by the subtraction method. Okay, so for the subtraction method, you just look up here and you are going to be subtracting both sides of the equation. Okay, so you have 5x minus 2x, so 5 minus 2 is going to be 3x. Y minus y will give you -0, or plus 0, or -0, it doesn't matter. It'll give you the same answer. And then 23 minus 14 is 9. So then you get 3x equals 9. Then you divide by 3 on both sides. And you get x equals 3, because 9 divided by 3 is 3. Okay, that gives you the first part of your solution. Your x value is 3. Okay, but then you have to find your y value. So you just come back up here to one of these original equations and plug in, I'll just use the top one, 5 times 3, replace the x with the 3 that you solved for, and then 5 times 3 plus y equals 23. 5 times 3 is 15. So 15 plus y equals 23. Then to get y by itself, we need to subtract 15 from both sides. And then you get y equals 8. Okay, and so your solution, what the answer you're looking for this problem, is 3, 8. So when you solve by using the subtraction method, you just simply subtract both sides of your equations. Then you do the math and find the value for either x or y, whichever one is not eliminated up here when you subtract. So you find that value, and then you bring what you found back up to the original equation, plug it in, and find the value for the other variable. Okay, now we're going to solve system of equations by addition method. And so I changed these equations just a little bit, the system of equations that we use for subtraction a little bit. I changed this to 28 and this to 14. And then I change the sign here to negative so that when we add, we will eliminate the y variable. So you add both sides, and you get 7x, because 5 plus 2 is 7. Positive y plus a negative y is going to give you 0. Equals 28 plus 14 is 42. Okay. Oh, and then we'll bring that down. 7x is equal to 42. Then we'll divide by 7 on both sides to get our x variable isolated. So then we get x is equal to 6, because 42 divided by 7 is 6. Okay, we have the first part of our solution. The x is 6. Come up to our original equation. 5 times 6 plus y equals 28. Okay, so 5 times 6 is 30. Plus y equals, my goodness, I can't write that, 28. Okay, and we need to subtract 30 from both sides. So we get y equals, and 28 minus 30 is negative 2. So now we have the y variable. We solve for the y variable for our solution. So the answer to this system of equations is 6, negative 2. And that's how you solve systems of equations by addition. Now we're going to solve systems of equations by using substitution. Okay, and the substitution method of solving systems of equations, you want to be able to get one of your equations to read where it tells you what one of the variables isolated, so that you know what one of the variables is equal to. So right here you have that. You have x is equal to y minus 3. So you don't have to do anything to put this to show that any of the variables equals what any of the variables equal, because you have it. X equals y minus 3. If it wasn't solved for x, you might have to solve it for x or solve it for y just to get one of your variables isolated. So you could use the substitution method, okay? But what you do with the substitution method is, once you do have an isolated variable on one side of your equation, then you go to the other equation and you can substitute what this equation says that variable is equal to into the next equation. Let's go ahead and work this out so you can see what I'm talking about. Alright, so you have 5x plus 3y equals 1. So you're simply going to come down here and start rewriting your equation. You're going to rewrite your 5, but then when you get to x, up here you have what x is equal to. X is equal to y minus 3. So you're just going to plug that in for x. Y minus 3. Okay, then you're going to keep writing your equation. Plus 3y equals 1. Okay, now we need to multiply 5 by y and multiply it by negative 3. So we'll get 5y, because 5 times y is 5y. And then 5 times negative 3 is negative 15. So minus 15 plus 3y equals 1. Okay, go ahead and add your variables that are the same. So 5y plus 3y is going to give you 8y. Okay, make sure you bring down your other numbers. Minus 15 equals 1. Okay, we're trying to get y isolated by itself, so now we're going to add 15 to both sides. Not sure what's happening here. Hold on one second. Okay. So just adding 15 to both sides. There we go. So now we get 8y. 1 plus 15 is 16. So 8y is equal to 16. Then divide by 8 on both sides because we need to isolate the variable y. And of course you get y is equal to 2 because 16 divided by 8 is 2. So we have the first part of our solution for this system of equations. Our y variable is equal to 2. Now we need to come back up here and find the number that x is equal to. So what we can do is say x, just take that original equation and plug in 2 for y. So x is equal to 2 minus 3. So x then, of course, is equal to negative 1. So we put that in our solution here. And this is the answer to that system of equations. So with substitution, you're just substituting what the variable is equal to into the second equation, or into the equation that isn't solved for a variable. Okay, then you just do the addition and the multiplication, the addition or subtraction, and you solve for one variable here, and then you plug in what you find here for up here into the original equation to find the other variable. Okay, now let's move on. The last thing we learned with this chapter was using the multiplication principle to help you solve systems of equations. This is when you can't automatically see, or you wouldn't automatically be able to eliminate one of the variables, so that you could use the addition or subtraction method to solve the system of equation. So the main thing to remember about using the multiplication principle is that you want to look for what you need to multiply by in either equation or in both equations to be able to eliminate either the x variable or the y variable when you add or subtract. So I have one example here, and in this example, as you can see, you have 3x and 5x, then you have 4y, 2y. So which variable would be better to eliminate? Well, if we eliminate the y variable, we only have to use the multiplication principle in one equation here. So if we multiply this equation by 2 on both sides, multiply it by 2 there, and here. This will eliminate our problem. And our problem right now is that we couldn't originally eliminate any of the variables by using the addition or subtraction method. Okay, so if we multiply by 2 on both sides of this equation, we get 10x plus okay, we get 10x plus 2 times 2 is 4y. Equals negative 5 times 2 is negative 10. Okay, and then we'll just move the other equation over here. Three x plus 4y equals 11. Okay, and so then for this, okay, for this we can use the subtraction method because we want to eliminate the y variable here. And if we do 4y minus 4y, we'll get 0. Okay, so we'll use the subtraction method on both sides. We'll subtract. So 3x minus 10x is going to be negative 7x, and then 4y minus 4y is going to be 0, so plus 0 equals 11 minus a negative 10. Remember, when you minus a negative, it's adding. It switches to addition. So 11 plus 10 then is going to be 21. And then you bring that down, negative 7x is equal to 21. Okay, and then we want to isolate the variables, so divided by negative 7 divided by negative 7, so x is equal to negative 3. Okay, that is the first part of your solution. So your x value for your solution is negative 3. Now you just need to find your y value. So you come back up here to your original equations. You get 3 times negative 3 plus well, if I can draw it here for you guys, 4y equals 11. 3 times negative 3 is going to be a negative 9. Plus 4y equals 11. Okay, then we want to isolate y, so we're going to add 9 to both sides. Okay, so we get 4y equals, if I can make equal signs here, which is not working very well. I'm so sorry. Sometimes the mouse doesn't cooperate. Okay. Equals, that's better. Okay. 11 plus 9 is 20. Okay. Then we're going to divide by 4. And divide by 4, because remember we're isolating that y variable. So we get y equals 20 divided by 4 is 5. So y is equal to 5. So that is the other part of our solution for the system of equations. We use the multiplication principle to be able to isolate a variable by using the subtraction method in this problem. Remember, with the multiplication method, you're looking for how you can isolate one of those variables, what you can multiply by in one equation or both equations to be able to eliminate a variable, and then use the subtraction or the addition problem. So it's just an extra step that you can use to help you. That's all the review for this chapter. I hope that these samples will help you as you study for the test. And let us know if you have any questions through email, or we'll talk about it a little bit at the beginning of the class before we take the test. Alright guys, have a great day on Monday and study hard.